Hello, this is András Belvárt for Pluralsight. I am very excited to present you my first course, Kinect Interaction with WPF. Since you are watching this course, you have probably heard of Kinect, Microsoft's natural user interface device originally invented for the Xbox. The Kinect sensor is an awesome device incorporating a microphone array which is able to listen to just a certain direction, a standard web camera, and a depth sensor which allows the computer to see distances instead of colors. The depth sensor, along with some very clever computer learning-based algorithms, allows us to detect people standing in front of the sensor and track a number of points on their bodies. This is called skeleton tracking. It can track the whole body, but what you are seeing here is the so-called seated mode, which means that the skeleton tracking only cares about the upper body, hands, neck, and the head. The Kinect sensor was so cool and so popular that hackers immediately connected it to a PC. In a few weeks after the initial launch of the Kinect for Xbox device, they managed to extract data and do all kinds of crazy and awesome things with the output of the depth camera. At this point, Microsoft has realized that the Kinect can be used for much more than display games on Xbox. Thus, the Kinect for Windows initiative has been born, which created the Kinect for Windows SDK, making it possible and legal to use the Kinect's capabilities outside of Xbox gaming. This course focuses on one extension of the Kinect for Windows SDK, the Kinect Interaction, which has been part of the Kinect for Windows toolkit since version 1.7. You can find other courses in the Pluralsight library to get started with the general Kinect for Windows SDK. So what is Kinect Interaction? Microsoft says that Kinect Interaction allows Kinect-enabled applications to incorporate gesture-based interactivity. I find this definition a little bit too vague. My definition is that Kinect Interaction makes it very easy to create mouse-like interactions with Kinect, where you can control a cursor on the screen with your hand in the air, pressing buttons and scrolling through lists. So when would you use Kinect Interaction? It is obviously dumbing down the Kinect by only focusing on just one hand, while the Kinect could track dozens of joints on your body. For example, if you are creating a map application, your user would be much more productive using their feet to zoom and their body to turn instead of pressing a zoom button. Still, there are certain tasks where the familiarity of the cursor-driven interaction is a huge advantage. For example, selecting items from a list, such as points of interest in the above-mentioned map application, is a good candidate for Kinect Interaction. Creating a hand-cursor interaction model based on the existing skeleton tracking of the Kinect SDK is fairly easy, at least up to a certain point. When it comes to being able to handle multiple users, identifying their primary hand, mapping the coordinates of their hands to the screen regardless of whether they are a tall basketball player or a 6-year-old child, this is when things become increasingly difficult. You will also need a proper press detection with the right user feedback and a grip detection, which is also very difficult to implement. And so is integration with existing control frameworks such as WPF. These are the problems that Kinect Interaction can help us with. Namely, it offers the following features. It can detect and work with up to 2 users. It can help deciding which user has control, which is important to avoid chaos if there are multiple users in the room. It also has a clever algorithm that helps deciding which hand of the primary user has control. Kinect Interaction can also detect press gestures, which is similar to when you press your hands toward the screen as if you were pushing a brick bank into a wall in an Indiana Jones movie. And it can also detect whether your hand is open or closed, which is called the grip gesture. And finally, Kinect Interaction offers tight integration with the WPF control model, which makes it almost as easy to create an application controlled by Kinect as if you're creating a mouse or a touch application. You don't have to use Kinect Interaction with WPF. There is a pure .NET and even a native API for these features. However, WPF is Microsoft's most mature UI framework, and it integrates well with XNA and DirectX while incorporating enough flexibility to suit modern needs. It makes sense that Microsoft has created a set of WPF controls such as hand cursors, buttons, and scrollable lists that work out of the box. In Module 2, I will show you how to install the Kinect Interaction Toolkit and create your first application using Kinect Interaction. I will show you the WPF controls in the toolkit and how primary user and primary hand selection works. In Module 3, I will show you how to customize this user selection behavior and the built-in controls. You will see how to change the colors, layout, and even the behavior of the controls, including the hand cursor itself. Some of these changes will also require modifying and recompiling Microsoft's source code. In Module 4, I will discuss the foundation of Kinect Interaction, the interaction stream, which provides the lower-level, framework-independent service that you can use to experiment with your own interaction model, or if you want to take advantage of Kinect interactions outside of WPF, you can do so. Let's get started.